So page 75. So before we talk about domain and intercepts, we're going to revisit the slant asymptotes. Okay, so here is a rational function that has some asymptotes to it, right? And so let's go ahead and figure out what all the discontinuities are. Can I factor the numerator? Yes. So f of x equals, and this is going to factor into what? X minus 1 and x minus 3, right? All over x plus 2. All right, so does it have any point discontinuity? No. Does it have a, so let's just list them out. So we got point discontinuity, none. Does it have a vertical asymptote? Yes, what is it? X equals negative 2. Does it have a horizontal asymptote? It's top heavy. Top heavy? No. And then slant asymptote. Should it have a slant asymptote? Yes, especially since we're revisiting slant asymptotes, right? Okay, so let's do some synthetic division real quick. Or you could do long division. It doesn't really matter either way. And so it's going to be 1, negative 4, and 3. It's going to give me 2. Oh, no, it's not. It gives me 1. Good Lord. It gives me 1, negative 2, negative 6, then positive 12, and 15. Okay? So we know that our slant asymptote is y equals what? X minus 6. Now, can any of you tell me why we just ignore the remainder? We just throw it out just because. Does anybody know? Okay, so I'm about to tell you. Because I didn't know either. I just knew that's what you did, but then that bothers me. Like, there's got to be a reason why. And then when I Googled it, the explanation I got about limits, I was like, oh, that makes sense. And then after I overthought it, I thought that still doesn't really explain to me why we ignore it or what it really means. But then I talked to Mr. Ackerman. He the skies parted and the birds sing, and it all made sense to me. Okay, so first of all, because we do this and we don't actually write out the whole quotient, right? If I was to write this out after I do my synthetic division, what this gives me is x minus 6 plus 15 over what? X plus 2. Okay? Everybody agree with that? Okay, so if you, and you may have already thought, like, it didn't really click to me until he wrote it out like this, and this was my first aha moment. Because I had never actually written it out, because I just knew to ignore the remainder, when I did it like that, if we use the remainder, well, this is the same function, right? Basically, I just reduced it. It's just a different way of looking at it. Everybody agree with that? Because nothing really went away, because I'm actually dividing it. It's not like me looking for a factor. Because, when we use if x plus 2 was a factor when we do that, yeah, it's going away and we're factoring it out. Well, that's not what's really happening here. This is literally division, so this becomes this. Now, so that doesn't explain it, but at that point, it clicked to me and I was like, oh, well, no wonder you can't just use the whole thing, first of all, because that is the same thing, right? But this has a meaning. So when we get this y equals negative 6, and I put the graph down here so we didn't have to spend time graphing it, and you can see the asymptotes and stuff that are in there. So this is your vertical asymptote, and the scale's weird, but it's at x equals negative 2, and then this really is y equals x minus 6. What that remainder means, because our remainder, so we can see it down here, was it 15 over x plus 2? Okay. That remainder is the distance the function is from the slant asymptote. So the perpendicular distance here, 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 I should probably use a different color so you can see better. This distance right here is 15 over x plus 2. And I've said, then I've said, oh, well, that makes sense. So then I was kind of stuck on, because that was before we actually graphed it. Kept saying, but we get closer and closer to an asymptote. So how does it stay the same distance away? And he kept saying, it doesn't. It's 15 over x plus 2. And then Miss Archer came in, and then she was like, well, so it stays 15? And he kept saying, no, it's 15 over x plus 2. Like, no matter how many times he said it, it wasn't registering in our brains. Then finally it clicked on me. Well, clearly the distance is changing because x is changing, right? So as I was like, oh, now I get it. Like, because he didn't really say it that way. I think he was just repeating himself, like, seriously, get it. So as x gets bigger and bigger, and x gets closer and closer to infinity, what happens to this fraction? It gets smaller and smaller. It gets closer and closer to 0. That's why the function gets closer and closer to that asymptote. Does that make sense to you? And that was the explanations that I found. Well, because it's a limit, and, you know, it approaches 0. And so at first I was like, oh, that makes sense. And then I thought, it still didn't tell me what that meant. So what that is the distance. And so then, you know, as we kept asking him questions, poor Mr. Ackerman, said, well, why isn't it the distance to this side of it? It is. It's just really hard to draw because it gets really steep. So it is that distance and that distance. Like, I can't even do it well. But does that make sense? Like, and they just get really, really close together. So it's still the perpendicular distance from here to like there, to that side of the function too. Because this is smaller, smaller, bigger, bigger, because it's getting farther and farther away from the slant asymptote, not the other one. Okay? So that's what it is. It's the distance away from the slant asymptote. That's what that part is. So this is the distance the function is from the slant asymptote. So I thought, well, maybe I actually knew the reason why, but honestly, back in the day when I was in school, they didn't give us a whole lot of whys. It was kind of because I said so, do this, and you kind of had to come up with those things on your own. But as I got deeper and deeper into math, I realized it made more sense to me, and it would stick with me longer if I understood the whys. Because then it makes sense why things go together, and why you have to do this, and that sort of thing. It also helps you know what to do when you need to. And the same goes from over here. Like this, it's this distance all the way down, so it gets smaller and smaller and smaller. So as it approaches negative infinity, the distance approaches 0. As it approaches infinity, as x approaches infinity, then the distance approaches 0. That make sense? So I was excited about it. You may not care, but I felt like you needed to know. Okay. All right. Yeah, when Mr. Archer walked in, I was like, oh, he answered our question. Let me see if I can explain it to you. So, got it. I know. It's the little things in life. All right, so now let's talk about domain. So we're going to talk about these 3 things, and we'll go do them. So the domain is the first step before reducing. First and before. Okay, some of the other things we do after we reduce if there's a point discontinuity, but domain is the first thing you do with the whole thing that you have in front of you. Okay? X-intercepts. They come after reducing or after. When you reduce, what are you finding? What do you find when you have that? Point discontinuity. Right. So it's after finding point discontinuity. And then, so when you go to find the x-intercepts, you're looking for the zeros of what? The whole thing? Numerator and denominator? Just the numerator? Just the denominator? What are you looking for? Numerator. Numerator. Okay. So then, y-intercepts. We should know how to find x and y-intercepts, but we make sure we don't do anything weird. So this is, again, after reducing, which means it's after you find point discontinuity. I don't want you to think you just get to reduce. You should know that that's not okay, but just in case. So to find y-intercepts, we substitute what in for what? 0 in for what? X, and solve for y. There you go. Algebra 101. Before we go any farther, back on slant asymptotes, I wanted to give you a different term also. That when I was looking this stuff up, I realized that the word slant asymptote, yes, that's what they're called, and that's an okay term, but that wasn't the most common term that I heard for these, and so I wanted to make sure, does anybody know a different way to say slant asymptote? Oblique, okay, good. So oblique asymptote. Do you know why we would use the word oblique for that? Whew. Where are your oblique muscles? Right here, right? If you've ever done crunches, these are your obliques. What do your oblique muscles let you do? Lean over, right? It's all tied together. An oblique triangle, an oblique pyramid, they're all leaning. Okay. I just want to make sure the word oblique was in your mind with those asymptotes too. Okay, so we're going to find the domain. So we do the domain before we reduce, right? And so we still need to factor to make sure that we can see everything here. So this is x minus 2 over x minus 2 times x plus 2. Okay, so does this have point discontinuity? Yes, it does. Do we really care? Not really. Oh, wait. Oh, that's right. So what is our domain here? Anybody know? If I did reduce, okay, when you do reduce, these two would cancel out. I'm not going to because I don't need to here, but these two would cancel out, which would leave me 1 over x plus 2, which means this function acts like 1 over x. What's the domain for 1 over x? All real numbers except for 0, right? Okay, and but here, our domain is not all real numbers. What can we not have? Plus or minus 2, right? So x cannot equal plus or minus 2. It's basically whatever's going to make the denominator 0, right? That's all it is. So this is your domain. Domain. Are we okay with that? So what is your domain in the second one? It's negative 11? Can't be. So x does not equal negative 11. That's the easiest way to write it. There's other ways to write it. It's really the easiest way to write it, and it's okay right now. What about number 3? What's the domain? What can't it be? Plus or minus 5. Everybody good with that? Easy enough? You can do domain. Right? Okay. So let's look at the X-Intercepts. Okay, so if I ask you for the X-Intercepts, your answer has to be in what? Right? If I ask you for the zeros or the solutions, you can put a little set. On your homework, I did put, I changed it to zeros so that it's just easier than ordered pairs. But when it says X-Intercepts, make sure you know it's in ordered pairs. All right, so this happens before or after reducing? After. Okay, so we got to go ahead and factor. So this gives me x plus 2 over, what does this reduce to? X plus 4, x minus 2. Okay. So can I reduce? No, I cannot, which means that X-Intercepts, what's my X-Intercept here? Negative 2. Okay, so my X-Intercept is a point. It's negative 2, 0, right? Your zeros would just be negative 2. Everybody okay with that? Y'all know how to find the zeros, right? I really shouldn't even have to review this. I just want to make sure you know what order you have to do it in. Okay. Factor the numerator here. What do I get? X minus 4 and x plus 4x minus 5. And then here it is x minus 4, x plus 4. Okay, can I reduce this one? Yes. Okay, so just for the sake of keeping up with what means what here, that means I have point discontinuity. I know it doesn't ask for that here, but on your homework you're going to have to find it all anyway, so it might as well talk about it as we do it. I'm going to cancel these out, right? So that's going to leave me my point discontinuity. My x value is a negative 4. For my X-Intercept, then I just do this, what this leaves me with then is x minus 5 over x minus 4. Okay, so my X-Intercept is what? 5, 0. And then the y value for my point discontinuity would be negative 9 over negative 8. So it would be 9/8. Everybody good with that? Okay, you do the next two. Okay. So in 3, can I reduce anything? Can I factor anything? No. What's the X-intercept? None. There isn't one. None. All right. And then number 4, we're going to have to factor. So the numerator becomes x minus, what, 4x plus 2 over x minus 3, x plus 3. Anything I can reduce? No. Okay. So my X-intercepts then, okay, how many do I have? 2. So I have these 2. I've got 4, 0, and negative 2, 0. But remember, if you were asked for the zeros, all you have to do is negative 2, 4. So you know the difference. So I went ahead and left the notes like this. Homework says zeros to make it easier, but you should be able to do either one. We good? All right. Y-intercepts. Does this happen before or after reducing? After. Okay. So I don't have anything to factor or reduce. So then I plug 0 in for x. So it's going to give me negative 3 over 11. So my Y-intercept is what? 0, negative 3, 11. An Y-intercept, that is an ordered pair. It is a point. All right, so then here, this gives me x plus 3, x minus 3 over x plus 3. Can I reduce? Yes. If I can reduce, that means I have point discontinuity. What would the x value be for my missing point here? Negative 3, right? So then this reduces, and I get x minus 3. So to finish off my point discontinuity, negative 3 minus 3 give me negative 6. So there's the missing point. My Y-intercept is going to be 0, what? Negative 3. All right, y'all been finding intercepts forever. Yes. Okay. Do the next 2. I'll finish writing these down. Okay, so I can't factor or reduce here. Oh, goodness. All right, so I plug 0 in for x and solve, and what happens? What do I get when I plug 0 in? What's my answer? Like to the, is what? Well, 1 over 0, and then what does that give me? Undefined, no solution, right? Okay, so does it have a Y-intercept? No, so it's just none. Alrighty. Then on this one, can I factor that one? No, right? It doesn't factor. And so I can't reduce, right? But that's okay. All I need to do is plug in 0 for x. So when I do that, when I plug in 0 here, that term goes away, that term goes away, that term goes away, that term goes away. So all I'm really left with is 11 over negative 4. So my Y-intercept is 0, negative 11 over 4. Okay. Everybody good with all that? Okay. Now, before I give you your assignment, I want to show you this because I know how y'all are. If you get more than one piece of paper, you're like, oh my God, we got this packet today. Okay. So this is the original assignment. One-sided. Like if I gave you this and then I gave you this, you'd be like, oh my gosh, I'm going to do this one first, right? This is literally the exact same thing, except I spaced it out to give you room to work. Now it's 2 pages front and back that you have to staple, okay? So when you get all bent out of shape because you got a packet, I could have given you this where you got to cram everything on there, okay? It's exact same questions, okay? Unless I typed something wrong, which I don't think I did. All right.